thanks for coming. I hope you had a great lunch. I'm going to be talking about continuous delivery, cutting-edge continuous delivery using automated Canary analysis, using a tool called Spinnaker. Anyone heard of Spinnaker before? Okay, and who of you has been to the talk just before this one about Spinnaker? Okay, just a couple. Great, because I got an introduction as well, and I wouldn't be liking to repeat myself. But let's get started with introducing who I am. I am Andreas. I'm a solution architect at Pivotal. I am part of the application transformation team for EMEA. I'm from Belgium. And when I'm not at customers, I'm active in the Pivotal's Spinnaker team, which is a collaboration between the Spring team and Cloud Foundry of Pivotal R&D. And you can find me on Twitter using my handle. Also, after this conference talk, or after the conference, if you have any questions regarding Spinnaker or anything else, just let me know on Twitter. Great. So we're going to be talking about continuous delivery. And when we do talk about continuous delivery, the ultimate goal that we try to achieve is to deploy software quickly and automatically, right? And this can only be achieved if we're able to push new code to production without fear, right? So this kind of highlights the two opposing forces in our industry. On the one hand, we've got speed, and on the other hand, we've got confidence. And it seems like we've always struggled to combine these two together. When I started development, it's like about 15 years ago, I've seen people hot swapping code into production. Has anyone ever done that before? Okay, that's like half, right? I've never done that, ever, right? Surely. So there, you've got a lot of speed, but not really a lot of confidence, because there was no guarantee that this was going to work, right? So a more confidence-based approach was to test your changes before you actually push them to production, right? So we started to have manual tests, regression tests, and that worked until our application got too big, because then we needed to group these tests together. They're very expensive otherwise to do for every feature separately. So then, we had these release cycles, features grouped together, and that dramatically decreased our speed. So we had some confidence, true, but it was kind of 3 months, 6 months, a year before we could actually see our changes in production. So that's not really great, right? So logical next step, automate your tests, right? And that's what we do today as well. We write automated tests, so that helps to increase our speed and our confidence. However, with our move to microservices, distributed architectures in general, it really becomes hard to guarantee that whatever we're testing on an acceptance environment is going to work in production. Because with microservices, we're testing a moving target. Whatever we're testing in an acceptance environment could have already changed before we actually push it in production, right? That's the very nature of microservices. You can independently go to production with your microservices. So there's not really a solution to that, aside from having these fixed release cycles again, which we don't want, because that's against microservices. So what do we need to do? We need to look at other approaches to test our code, right? To test whatever we want to put in production. And some approaches that we have seen before are, for instance, consumer-driven contract tests. Right? That's a useful thing where we can test independent from one another, which is great. You've got Spring Cloud Contract, which does a really good job at that. However, that just focuses on the syntax on the contract that you're testing. It doesn't actually cover the behavior of your services. So it doesn't give you full confidence that whatever you're testing is going to work. So we've got to look further, and we should look at how we can test in production. Right? It sounds a bit crazy, right? Testing in production. But actually, we'll see throughout this presentation that it will give you more confidence and it's not reckless. So one tool that can actually do that, that can test in production, is Spinnaker by the use of automated Canary analysis. So first, let me introduce Spinnaker, right? Spinnaker is a multi-cloud, multi-region deployment tool built by Netflix, and it supports multiple different abstractions. It supports Kubernetes, but also Cloud Foundry, also VMs, bare metal, even DCOS, App Engine. So a number of different abstractions that you can use to deploy to with Spinnaker. And if you look at the major companies that have contributed to Spinnaker, you see, of course, Netflix, who have initiated this project. They have open sourced it, and at that point, Google has committed a vast amount of time and money into this tool. I think there's a team of more than 10 employees working full-time on this stuff. So that's considerate, right? Considerable. And Microsoft have also committed or contributed the Azure support. Pivotal has contributed the Cloud Foundry support. Right? So there's big companies behind this, and it's an open source project carried by Netflix and Google primarily, but also Pivotal and Microsoft are active in this community. So talking about Netflix, they have actually also got Netflix OSS. Is anyone familiar with that? Netflix OSS? Right, a couple. So Spring Cloud used to have Netflix OSS, or still there, of course, wrapped in Spring Cloud. So that's interesting because the Spring team was then using the Netflix code, but nowadays Netflix is also using Spring code, right? That's already for about a year or something that they actually formally announced that. So if you look under the covers of Spinnaker, you can actually see a microservice architecture, if you can call it that, using Spring Boot applications, right? So it's very familiar if you're actually having to troubleshoot anything or you want to contribute to Spinnaker. It's very familiar for us as Spring Boot developers. Right? And the Angular UI is being replaced by React right now, actually. So really useful setup, for us at least. And Spinnaker is being used by a lot of different companies. Also, big banks are using it. And that says something, right? If we talk about automated Canary analysis, so testing in production, you wouldn't really expect a bank to be doing that, but that's actually what they are doing because it gives you more confidence. And we'll see how that works in a minute. So Spinnaker has been contributed by Google and Netflix to the Linux Foundation under its own foundation called Continuous Delivery Foundation. So it really underlines the openness of the community and the way that they want to govern the evolution of this project. Right, so when we talk about Spinnaker, we have a vast ecosystem of integrations. We already talked about the cloud providers that we integrate with, but also CI systems. And CI systems are actually separate because Spinnaker doesn't want to be a CI system. It doesn't want to do CI. It knows that Jenkins or Concourse or whatever CI system is better at building applications, but not necessarily at deploying these built applications. So CI systems can then still do their job, right? Can still build your applications and can then produce an artifact, which can be stored in an artifact repository. Over here, for instance, on the left, you've got artifact support in Docker, GitHub, HTTP, so it's just an HTTP call you can make, S3 buckets, Artifactory, Google Cloud Storage, Nexus. So just any place where you can store your artifacts in, and then Spinnaker can pick up these artifacts and can then deploy them in a strategic way. Right, so that's pretty cool that you have all this support for that. And if we are going to do automated Canary analysis, we're going to use metrics. So where can we get these metrics from? It can be Datadog, Prometheus, Stackdriver, Atlas, SignalFX, and many more. But the only thing here which is important is that they support multi-dimensional time series data points. So as long as your monitoring solution supports that, then it can plug into Spinnaker, actually. Cool. So that's basically the ecosystem. But you might wonder, well, we're here at SpringOne, and Spring Cloud already had a solution for continuous delivery, right? They had Spring Cloud pipelines. So why don't you just use that instead of Spinnaker? Well, actually, it's no longer Spring Cloud pipelines. It's now called Cloud Pipelines because it has nothing to do with Spring, actually. It's just templating for Jenkins pipelines or Concourse pipelines. And that kind of worked up until a point, right? There are some limitations to that approach. Why? Because if you use Jenkins or you use Concourse for continuous delivery, you have to worry about what is my current state in production or in any other environment for that matter. Well, how does my application live in the clouds, right? Because that information is crucial if you want to have a strategic rollout. And the way that we used to kind of keep track of all that stuff was by using tags in Git. So we would tag certain commits when they were deployed to production, and then we would be able to use that information to then figure out what we have to roll back to or what kind of versions that we currently have where. But the problem is if you have any manual deployments, then you don't have any tags, and that gets really confusing. It's no longer accurate. Sure, you could say, well, we have a policy where you cannot no longer do any manual deployments. You always have to go through the pipeline. It's a good idea, actually. But what if you have multiple versions in production? What if you have multiple versions in different regions over multiple different clouds? How are you going to keep track of that in tags? Now, that's going to be a bit tricky, right? And especially if you want to do sophisticated rollbacks, then it gets really impossible to do with tags. So the state here is the problem. And that's where Spinnaker differs. That's where Spinnaker has an inventory where it keeps track of all your applications across all your clouds, all your regions, all the different accounts that you might have, and it shows it in one dashboard. And that inventory, that information of what actually is out there right now, guaranteed to be up to date, can then be leveraged to drive pipelines. And that's much more strong. It's a much more powerful solution than having just the abstraction of Git tags. Right? So that's the difference. Now, when we move to the cloud, right, then we might wonder, what are important things to think about when you engage on that journey, right? And one of the things that we quickly see is, well, when we go to the cloud, aside from a simple CF push, it gets quite complex after a while. You've got multiple different teams with multiple different people making multiple different changes across multiple different services, pushing to multiple different regions and availability zones, and perhaps even multiple different clouds. And you might say, well, we only have one cloud. We decided to use Amazon, right? Sure, but have you completely migrated? I don't think so, right? There's not that many companies that completely migrated to one single cloud provider. So you still have on-premise probably as well. So having that composite view of both together is really powerful. So Spinnaker offers a multi-cloud, multi-foundation or multi-environment, multi-account, multiple region view into one. And it takes the perspective of an application. Now, I hope I can show this picture a bit more in detail when we do the demo, because it's quite unreadable. But as you can see, my Rick and Morty app, which kind of already tells you what my demo will be about, you can actually see from that perspective of the application how it's currently behaving. And it doesn't show you separately the load balancers, separate VMs, separate disks. It's all together, right? It's from the perspective of an application. It's much more powerful than if you, for instance, have an Amazon dashboard or a GCP dashboard. You would have them separately grouped per resource. It's very hard to figure out when you have an application. What does that entail, right? What's currently used for my application, right? That's pretty difficult. And especially if you want to switch between develop environment, acceptance environment, production environment, whatever environment you have to log out and log into another account probably. That gets pretty annoying, right? So Spinnaker offers you this infrastructure view based on your application. And then the next thing, of course, cloud deployments are complex, and if people want to onboard, if you want to onboard teams into your journey to the cloud as an enterprise, then it could be useful to help them along a bit. Not everyone is completely aware of how a cloud works, or what the abstractions are, or what the concepts are that they're using, or what you have to think about. So when you build this continuous delivery pipeline, it could be good if you have a certain paved road in the wilderness of complexity of the cloud, right? Especially if you have multiple clouds to deal with. So Spinnaker can offer you pipelines that are templated, that offer some kind of an easy path forward with some guardrails where, if you're just starting out, then it's pretty straightforward, because you just take that default pipeline and you just do it through the best practices that it entails. However, if you want to become a power user, if you're more advanced, then you can definitely deviate from that and just choose whatever you want to do, right? So that's a powerful concept here. And of course, if you're in production, things might actually go wrong, right? It surely happens to me a lot that I have to roll back whatever I push to production. So the problem with rollbacks is that, well, you can automate them, but sometimes you don't really know for sure if whatever you have automated or whatever is going to happen is guaranteed to be successful, or that it actually is correct what you're going to do. Because rollbacks, they happen when you're actually stressed out, when you're under duress, right? It's when your manager is breathing down your neck. You have to do a rollback. You have to fix whatever you've broken. And then Spinnaker offers you this one-click rollback mechanism where it shows you exactly what it's going to do. It shows you the exact operations it's going to perform to get back to the previous state. And that can help you to create some peace of mind, to understand actually what's going to happen, and to kind of judge whether that's the right track to perform. So having the rollback capability is great, but when something is wrong in production, of course, it's interesting to make sure that not many people see it, right? So has anyone ever seen this picture before? Only 2, 3 people, perhaps 4? Yeah, when do you see this? Yeah, GitHub is down, right? If GitHub doesn't work, they show this picture. I think they mean to say that that never happens because unicorns don't exist. But the point is that there's only 4 people of the entire room that ever saw this. Right? It's because they make sure that whenever they fail, they don't have this huge blast radius. Right? Not everyone is impacted, only a couple of people, right? And that's important to also get into your pipeline. That whenever you deploy something, that you do it during the right time frame, and that you don't impact everyone all at once. So you could look at, for instance, traffic of your application, and then decide, based on when the traffic is lowest, that you should probably go to production at that point. But Netflix has also integrated the ability to link that up to the agendas, the calendar of the employees, so that you can say, like, okay, sure, we'll go to production when there's not much traffic, but that's mostly at night. So we also want to make sure some people are actually in the office to fix the stuff if the stuff doesn't work, right? So having this ability to include that in your pipeline is great. And you can set it up that your entire deployment is prepared up until the point where you want to switch the traffic. So you've got full automation, but the moment that your deployment window hits, only then you're going to go to production, right? You're going to switch the live traffic. So that's great to have as well. And then, of course, the deployment itself should be in a strategic way. And there's probably a couple people amongst you that are using Cloud Foundry, so you're probably aware of blue-green deployments that we can do there. We can do that as well with Kubernetes, of course. And blue-green deployments are also supported natively in Spinnaker as a strategy. So what that entails, if you're not aware, is it just brings up the new version as an entire cluster next to the old one, and then it switches over traffic using the load balancer. It can do that with assigning both versions to the same load balancer, and then kind of rolling back kind of detaching the old one, if you want to put it like that. So there's some benefits there. So with this approach, you're able to switch back to the old version really quickly because it's still running. It's a full cluster, right? So it's great. If there's something going wrong, rollback is super easy. But there's 2 downsides here. First downside, well, you've got all these resources consumed of this new version, right? This full cluster has to be set up, or a resource group, or server group, or however you want to call it. So you're going to be consuming a lot of resources. Might not be the best economically friendly approach. So that's something to look into. But also, when you switch over the traffic, everybody's actually impacted, right? Everybody's seeing this new version, and this might not be working. So this is something that we should probably improve. And rolling blue-green, or rolling red-black, like Netflix calls it, helps you to increment that how many people are actually seeing your new application, your new version. You can do that by scaling up the new version and scaling down the old version. You can do that also by more sophisticated load balancing strategy, right, where you just increase percentage of traffic or something like that. And every step of the road, you're going to take some time to validate whatever you're putting into production is working. And you can do that with a manual verification step. So you can just check it if it's working by going to the website or something. Or you can do some smoke testing. But it's not normal. Normally, this is not really very sophisticated, this validation step. And that's where the Canary approach, the Canary strategy differs. So the Canary strategy will make that much more sophisticated. So you will take every step you take in incrementing traffic, you will have an analysis of metrics. Metrics that are coming from version 1 and version 2. You're going to compare them with some judge that's going to judge whether this is actually good or bad. And you're going to automatically roll forward or automatically roll backwards. That's how that works. And I'm going to see that in practice as well. It's going to be a demo. Right? So the Canary analysis, that's an automated solution that checks, that analyzes statistically whether the new version is healthy enough or not. Cool. So to do that, you need automation. Right? You could try to do this manually, but we'll see that you might be mistaken to assume that whatever you see in the metrics at the given point in time is actually correct. Our demo will illustrate that. But for automation purposes, this is one example here of a pipeline. So you can just find an image in test environment, take that image, deploy it as a Canary in production. Then you might have a manual cutover. You have to wait 30 minutes to see if everything's going fine. If everything's fine, okay, great. We're going to do a blue-green deployment now. Blue-green deployment in production. Then eventually going to tear down the Canary because you don't need that anymore. You've already done a blue-green. You're going to wait 2 hours and eventually delete the old version in production. That could be just a pipeline, a standard pipeline that you might have. Now, Spinnaker does a lot of stuff behind the scenes here. So for instance, for this blue-green that we talked about, every stage that you see in this pipeline has a number of steps, and each step has a number of tasks, and each task maps down to a number of low-level operations. And sure, you could say, well, I can do all that stuff in Jenkins as well, right? I'm good at Groovy. I can write some Groovy scripts, right? We've been doing that before, so why should we be using Spinnaker for this? Well, Spinnaker does all this stuff for you, and I probably can say that I've written the same Groovy script many times before. I mean, it's always the same thing, right? A blue-green in Groovy, I mean, you just have the steps, right? You just have to code that every time again and again. You might have some library, but then how is that tested? Is that tested by just running the pipeline? That's mostly how you test this Groovy stuff, right? So that doesn't really sound very robust. And in a way, we have to kind of deal with the abstractions of the cloud provider by using the cloud provider CLI and map that to whatever we want to do with it. Why not just have the cloud providers commit something for us? I mean, give us some code that does this stuff, right? And that's what Spinnaker has. Spinnaker has support for all these clouds, and these clouds, these vendors like Microsoft and Amazon and Pivotal have contributed these operations, these tasks, and these steps to do that for you. So you don't have to do that again and again and again, right? Maybe, I mean, if you can see how many operations that are executed, maybe you're just going to skip a few because you don't care about that, right? So it's not going to be a fully robust situation there. So having this completely out of the box as composable stages, you just have to configure them and just couple them together into your preferred pipeline, and it's just a very powerful solution, right? And that's where Spinnaker really has an advantage over tools like Jenkins or Concourse for deployments. Right, so we're going to be talking about Canary analysis. So we're going to be talking about Canary birds, right? Maybe you know, maybe you don't, but the idea of Canary analysis or Canary testing or Canary deployment is that it goes back to the time where we would take a canary bird down into the mine, and that would actually test whether there's gas or not, right? And then the canary bird would sometimes die, but at least the workers wouldn't die, right? That's the idea. So we're going to be killing a couple of these birds here, and I hope there's no bird lovers. Is there any bird lovers in the room here? That's one. There's two. All right, four. Something. Okay, so I got a special slide for you because I appreciate that, right? So I hope you don't mind that we're going to be killing a lot of these birds. So just to give you a bit of comfort, pretty cute birds, right? I mean, seriously. Oh, really? Well, this is better, right? It's a bit more comforting, right? So there we go. That's enough of that. So we're going to be giving a score to these canary birds. We're going to be saying, well, this is a good bird, this is a bad bird, right? So the score is calculated based on these metrics and whether it's doing a good job or not. And if it's a score which is too low, too bad for the bird, right? But at least the impact won't be as huge. The blast radius won't be that big. So that's the idea. I'm just going to be looking at something like this. And we're going to be seeing this in the demo as well, so I hope it's a bit more detailed than on this projector here. But yeah, we'll see. So aside from that, from Canary analysis, we can also inject chaos into our system by using chaos monkeys. And as you know, Spinnaker is built by Netflix, and Netflix have this simian army, right? They have all these chaos monkeys that go into production and pull some plugs. So this can help you to make sure that you're resilient, that your applications are capable of recovering to failure. So you can have that also in your pipeline. It's out of bounds of your specific pipeline, but it can really help you make sure you have more confidence that it's going to remain working, also when disaster happens. Great, so we talked about a lot of stuff here, right? We talked about automated rollbacks, deployment windows, chaos monkeys, deployment strategies, automated canary analysis, and all this stuff makes you able to go faster than usual, with still having safety, right? So not just recklessly fast, but also being able to have confidence that this stuff is going to work. And there's also more stuff that we won't see in detail, but I just want to mention it. Cluster lock-in, traffic guards, manual judgments, conditional pipeline and stage executions and notifications. Maybe the first two could be confusing perhaps. So cluster locking, what it does is that when you have multiple pipelines acting on the same cluster, then it could get really hard to to figure out whether this is going to be deterministic, right? Whether this thing is actually going to work, because it could be that your pipelines are not meant to be doing the same thing on that cluster. So you might want to lock that cluster so that only one pipeline at a time can actually edit it or change it. So that's possible to set it up. And Traffic Guards goes one step further and it says, well, whatever you're going to do, whatever strange combination of pipelines you're going to execute, you will never, ever delete the last server group in production, right? It could be that you have this strange setup, this combination that you haven't thought of, that happens to, do some Canary deletion or something, and that would kind of impact what's on production. So just whatever you do, no downtime. That's what the Traffic Guard is for. So we're going to be seeing that we're going to be seeing some of these things in a demo. So let me introduce them. So this, this is kind of automated Canary analysis. Can be confusing. So I'm using a scenario which might be more interesting, right? And I'm using Rick and Morty for this. Has anyone seen Rick and Morty before? All right, so about half of the room. So I would advise everyone else to go watch it, because it's pretty cool. And there's season 4 coming up next month, so great. I'm a big fan. It's about this mad scientist on the right and this kid on the left. Mad scientist goes on these interdimensional time travel adventures and always takes this kid along, right? So that's kind of the cartoon. And there's 2 characters that we're going to be using from this cartoon. You might recognize them. On the one hand, we've got our green protagonist, which is Pickle Rick. And Pickle Rick is that mad scientist, right? Who turns himself into a pickle because he doesn't really want to go to family therapy and has a nice excuse. But, things don't really work out. He rolls into a sewer and has to fight rats and cockroaches. So, it's pretty bad, but he comes out victorious. So that's great. So he's a very stable version, predictable, and strong version that we can trust. So we want to keep that stuff in production, right? That's going to be our stable version. And on the other hand, we've got our second version, which is the blue antagonist, Mr. Meeseeks. And Mr. Meeseeks sounds good at first. And we're going to see that in our demo, that it looks good to start with, because he's a genie in a box, and it sounds good, because he can solve the task at hand. But he doesn't really want to do anything else. He just wants to disappear afterwards. The problem is, if he can't solve that task, he'll get aggressive. And we probably want to roll that back. So he's our dangerous, chaotic, and unstable blue version. And I know this is the most interesting part of my entire presentation, so I put some more slides in this. So we've got Mr. Meeseeks here. This is the backstory. He wants to make this guy play golf. He can't do that, so he spawns another Meeseeks. And these guys spawn more Meeseeks on their own. But this guy can't play golf, right? So eventually they start to threaten people, and it gets really bad. So this is our Canary here, and we're going to want to roll this back. But this is going to be rolled back based on metrics that we'll be able to get out of these applications, right? So that's the backstory, right? Is it clear? Any questions? No? All good? All right, let's do it. So you can also actually help me out here. I will need some traffic to generate some metrics. So if you go to this address here, bit.do SpringOne, you can also take a QR picture. Then you will currently see what's on production, right? So that's, hopefully the green version. Green? Yes. Okay, good start to the demo. All right, so it's pretty simple if you didn't get the QR code. It's bit.do/SpringOne, one word. Okay, great. So what does our demo environment look like? So there's a couple of setups, a couple of configurations that I've done. There's 2 paths to Spinnaker, actually. So we start from a code repository, so our application. And then either we build a fat jar, or we build a fat jar in a Docker container. Docker container would go to Kubernetes, fat jar would go to Cloud Foundry. So in our case, we would go through Google Cloud Build, put it in the GCR repository. Then that gets pushed into GKE Kubernetes clusters. And in the meantime, we're going to be using Datadog as our metric store. Right? Make sense? Pretty clear, right? Great. OK, so I'm going to have to zoom in a bit here to make it readable. Yeah, well, is this good? This is pretty good, right? In the back? Yeah. Awesome. OK, so we've got our application Rick and Morty here. Let me look at infrastructure first. So let me just check for the time. All right, awesome, right on time. So here we see that we have a dev cluster, which is, as you can see by the icon here, Kubernetes, Right? We have a dev version, we have prod as well, and you can see there's 4 instances running of version 10. We also have some other resource groups still there, but they're downscaled to 0. So we can easily roll that back, right? If I want to roll that back, I just have to click a button, and it will spin up the instance of the old one. Great. I also have here, as you can see, some Cloud Foundry stuff. I'm not going to be using that, but if we need it, we can just push to that environment as well. So this is great. Let's take a look at production as well. So we got some load balancers here, which are mapped to services. So the concept of load balancers is just a common concept, because that's what Spinnaker does. It doesn't try to look into specifics of each cloud, because that wouldn't work, because it's just multi-cloud. So it's giving you some concepts like load balancers that then map down to a service in Kubernetes or a route in Cloud Foundry. Right? Makes sense. So here we've got a service for our dev cluster and a service for our prod cluster. And as you can see here, only 4 instances currently running. So let's take a look at this service. It has an ingress. So let me check it out. So it's green version, right? It's pretty green. So let's make a change to our application. Right? Let's make it blue. So how we are going to do that? We have this Spring Boot application here. It's not that sophisticated. It's just, it's got Spring Boot application. It's got some configuration and the controller. And the controller, if you know, well, this is completely unreadable. So is this better? Yes. OK. So as you can see here, it just maps the root endpoint to a view called pickle-rick. And we're going to be changing that, right? So let's go here. I'm going to change that in GitHub, because that's what all great developers do, right? They change stuff in GitHub. Me6, right? So now we're going to return the Me6 view, which should be blue, right? And there's one more thing. We want to make sure this version misbehaves, right? Like Me6 do, right? And so how can we do that? We can do that by creating some chaos in here. So there's just a little int that we're going to be increasing. And it's going to have an effect on the sleep time of this method. Now, this thing is a demo app, right? So it's not really representative of whatever you have currently in production, right? So what I did is to sleep a little bit based on a random generated integer. So it's going to sleep by default. Currently in pickle-rick, it's going to sleep between 0 and 100 milliseconds. You wouldn't notice that, because it's like super short. But still, it's going to make that delay, right? It's going to create that delay. Now, what we're going to do is we're going to increase that delay just a little bit, right? So I'm going to add 20. So 20 milliseconds will be more, always, by default, on Me6. Now, I'd like you to think of this as, there's this little thing here where you can have your blue version and your green version currently deployed on, they can be together deployed on production, this which we're going to do, right? And it could be that you would think, if you look at a given moment in time at your metrics, that actually pickle-rick is worse than Me6, right? It could be that you're looking at these metrics and that by chance, pickle-rick, our green version, is always having a random integer which is close to the hundreds, right? So then your delay would be always around 80 to 100, right? And it could be that Me6 by chance has a random which is very low, right? And it could be that you're always 20 plus 0, 20 plus 10, 20 plus 20. So in a way, you could judge based on the metrics, if you're only looking at a certain point in time, that Me6 is healthier than pickle-rick, right? So the message here is that actually you need to look at trending. You need to look over a longer period of time with enough data points, and then you're going to see that Me6 are in general 20 milliseconds slower than pickle-ricks. You see what I mean? This is to make it a bit more realistic, right? So let's commit this change. So we've added 20 milliseconds of chaos, and we've changed the view. So added chaos. There we go. So committing that. So this thing will now trigger a build. So if we look here, it's triggered the build in Google Cloud Build. There we go. It's just going to do Maven install, and then it's going to create a Docker image, which it's going to push to the Docker registry. So then eventually our pipeline will be triggered. Let's take a look at our pipeline. So Spinnaker offers you, of course, the possibility to use that infrastructure information to drive pipelines. And in this case, our pipeline, the first pipeline, is just deploy this stuff to dev, right? Just deploy. Let's have a look at how that works. So we have some configuration here. And here we can see some triggers, automated triggers. It's actually really bad resolution, but yeah, okay, it'll have to work. So the Docker registry here is being watched for changes. If there's a new image being pushed, then it's going to trigger the pipeline. It's pretty basic stuff, right? But it's going to put that in an artifact. And so that we know we have artifacts, the concept of artifacts, which we can then use in future steps of the pipeline. Right? So in this case, it's going to map to Rick and Morty Docker image. So we're going to have that information here as well. We can have another trigger which looks at GitHub itself. And in this case, it's going to look for manifests. So if the manifest changes, you don't necessarily have to build a Docker image to deploy something, because it's just a manifest how to deploy an existing Docker image. So you can use that information. And actually how we set it up is if you haven't actually touched the manifest, then you will actually have a default artifact. So it's always going to find a manifest. It's just going to be the latest one. Great, because we're going to be needing that. Let's take a look at the next step of our pipeline. So we just got that information. Then we want to deploy a namespace. Now, deploying a namespace can be done, of course, by having a manifest somewhere in our code repository, or we can define it here. So I'm just taking both approaches here for the demo purposes. And in this case, it's going to be declarative, right? If the namespace is already there, it's fine. It's just going to try to reach that same state where it wants to be. In our case, it's already there. But this is great if you delete, for instance, your namespace by accident. Then your pipeline will just completely provision everything again. So once this namespace is there, it's going to deploy the application. And the application is then deployed by taking an artifact, the Rick and Morty manifest, and using that Docker image that it resolved from the registry, and inject that into that manifest. So you don't have to change the manifest constantly. It's just going to replace the image with the latest version. It's pretty useful. So there we go. And let's see how that works. So it's already, the namespace is there. That's fine. Nothing to change. It's available and stable. And now it's deploying the application. So the application is now, it's actually the manifest that I'm using. It has a service, and it has a deployment. The service is already there, so that's fine. But the deployment is new because there's a new Docker image. Let's take a look at infrastructure, how that works. So here we have version 13, which is green. If I refresh, now we have 14 here, which is just starting up, and it's going to do that in a rolling upgrade. A rolling update, which is basically just a deployment strategy from Kubernetes, but you could also use native Spinnaker deployment strategy, so you don't necessarily need to use deployment abstraction, to like the deployment resource of Kubernetes. You could even do that with server groups. You could do that as well. So you don't need to use always the Kubernetes abstraction of deployment to do this strategic rollout, which is pretty fun. So let's take a look. OK, so as you can see, it's rolling it now. And if I go to the developer service, so develop service, there we go. Then I should be seeing the new version. And it's blue, right? Great. So develop looks good. I mean, me6 initially look good, right? It's just a good idea up until it goes wrong, right? So let's push this to production because it seems to be fine. So our next pipeline is already triggered, and we need to catch up here. So the configuration is just, it's going to look at the development pipeline. If that's successful, yeah, go ahead. So here we're going to find a baseline version and a Canary version. The baseline version is going to look at production, what's currently running in production. And the Canary version is going to look at development environment. And development environment here, as you can see, is just going to target dynamically a deployment called develop in development environment. Take the newest one, whatever. So this is great. But why do we want to deploy a baseline? Right? You might just have a Canary, and that might be just sufficient because you already have a production environment running with a production version. Why would we want to deploy a baseline version as well? If I look at my infrastructure, you'll see it will actually have, I have to zoom out a little bit, sorry. If I refresh here, I go to my load balancer, it's easier to see. You can see that now I have a Canary group and a baseline group, each 2 instances. Now, why is it important to have a baseline? It's because you would be comparing different things here. You would be comparing an application that just started up with an application that's been running for a long time. You can't do that because you have startup spikes perhaps, or you're warming up caches. Or for instance, the other way around, the production version might have a memory leak that has been building up over a month or something, and the new application won't have that. So you wouldn't be actually having this level playing field. So if you now go to production, you'll see that we have a new version there. Let me help you out and generate some load for you as well, so we have enough data points, right? So I'm just going to go here, and as you can see here, if I zoom in, you have pickle Rix being returned and me6 being returned once every couple of calls. So our Canary analysis is now started. So the Canary analysis, if we zoom out a bit, zoom in a bit more, zoom out a bit. It's hard with this resolution. Here you can see that we have now a warm-up wait. So we have 1 minute where we just wait, and we don't actually do anything. We don't do any Canary analysis. We don't do any. We don't gather any points because it's just the spike of starting. We just want to get rid of that. So after 1 minute, we start with an interval, and the interval will collect data. It will collect data from the baseline and from the Canary, and then it will compare that, and it will then judge whether that's successful, go on, continue, or roll back. So you can help me out by just refreshing and creating some data for me. So maybe can you show me which version is currently there, so I could see like it's a lot of blue. I'm going to take a picture. Great. Yeah. So it's about like normally it should be 2 instances out of 8, right? So that's the ratio here. It's pretty straightforward, just round robin load balancing. So now we've got 1 minute of traffic, right? If I go to production here and I refresh, I should have, is this production or is this dev? Okay, this is production. Do you see sometimes have that? So if I now look at my Canary, it's now actually comparing the metrics, and it's going to give me a score. And the score here, if we check it, is 30. Oh, it's not good enough. Let's take a look why. So here, as you can see, or not, well, maybe a bit. I can zoom a bit more at the bottom. This resolution is really bad. This is still visible, right? It's just a trend. So here you can see that it now noticed that the rendering time average was 40% higher in the data points that it gathered. And for the maximum, you can see a clear distinction, right? And you can also see that in the B-swarm box plot, where you can see that the data that we gathered, the standard deviation is completely different. Right? There's not even outliers that are overlapping. So that's really, I mean, I got lucky a bit because normally with this kind of with these kind of 1 minute windows, you don't have enough data. But here we have enough data where we already can see that this is a bad trend. I can show you some other reports from before where we have many more data points, as you can see here. Hold on. So Canary analysis, here we go. Summary. So we can take this one here. And here you can see one that I deployed before where we had many, many more data points and actually a positive improvement. So you can see here that actually there's a minus 30%. This was actually an improvement of our performance. So it definitely was happy with that, so we moved on, right? So you can see that eventually the trend becomes visible over time, right? So this is great. So now we normally roll back, but I've put in this little manual judgment here to show you a little bit more about the pipeline. Normally it's already rolled back automatically. So manual judgment, why would we even have that in our pipeline? Right? That's the distinction between continuous delivery and continuous deployment, right? It's this manual intervention. Actually, it might be a good idea to have that, even if it's possible to completely do it technically automated. So the manual judgment is the idea of a gut feeling for people, right? It's important that the human gut feeling is still something that we take into account. Because it might be that you heard some colleague tell you that they're going to make some configuration change somewhere and your new version will be impacted by that. Right? The computer might not know that. So while the Canary analysis might say, okay, everything is fine, you might say, okay, wait, I don't trust this because I know something's going to happen, right? Because I heard this stuff. Could also be that eventually you want to align this with some marketing campaign or something, right? Some emails that need to be sent out. So then you probably also want to have that big red button where even business can actually interact with. So we're going to stop, right, because it was bad for the analysis. So what we see now is that the Canary is getting deleted and the baseline is getting deleted. Right, so that's automated, and let's take a look at our infrastructure. So if we look at our load balancer here, right now we have these 8 instances, but if I refresh, there's only 4. And if you now refresh your production environment, you'll see it's automatically rolled back to green, right? That's kind of how it works. And of course, you know, this is the demo, so there's some decisions taken here which are shortcuts, but we'll see in a couple of best practices in a minute how you can improve this process. So this can be something that helps you create more confidence when you're actually going to production. It doesn't mean that you have to throw away all your tests before you go to production, of course, right? It's something extra. Right? So this is great. So let's take a look at the next step. Oh yeah, maybe I can have, still have some time? Yes, I have like 3 minutes left to explain to you how these metrics actually got evaluated. And it's pretty straightforward. It's using a library called Macrometer, or is it Micrometer? What is it? Micrometer? Okay, great, Micrometer. So in Spinnaker, you have a stage called Evaluate Canary variables, or Evaluate variables in general, where you can put some variables and give them a name. So in this case, our deployment type for Canary was Canary. Right? This is going to be an environment variable that I can then use. I can inject that as an environment variable in my pod, right? In my deployment that I'm doing. And as you can see here, so the Canary would then be a value for deployment type. Now, that information, of course, an environment variable in Spring Boot is very useful. You can use that, as you can see here, with a value annotation. Then that is actually being injected into Micrometer, right? And as a common tag, which means that every metric that you're going to generate using that's more coming on the slide, so wait with your picture. So that's going to annotate every metric in Micrometer with an extra tag called deployment, given the deployment type here that you've put as an environment variable. It's in this picture is production, but it should be Canary, right? Because it's set as Canary. But you should do that for all your versions, so for production, for development, for Canary and baseline. So you can identify where the metrics come from. So this information needs to be put into a data store, right? Into a metric store. And that would be, in our case, Datadog. And Datadog has a Spring Boot dependency, which allows you, it's actually a Micrometer dependency for Datadog that allows you to forward all the metrics of your application straight into Datadog. So you just add some properties in your YAML or your properties file. You inject that from a secret, for instance, in Kubernetes. Could be a secret, where that information is then available as environment variables for your properties to consume, and then it's going to just forward that into Datadog. So here you can see Datadog having a number of different tags available for whatever is currently on production, and I can actually show you that in real time here as well. Here you can see that for the time that we actually were using a Canary and a baseline, we had these extra metrics, and of course our production environment never changed. Right? So we still have that. So then once we actually have that in Datadog, we can then consume that in our Canary analysis stage, as you can see here. So we use that to filter whatever metrics that we want for our specific baseline and our specific Canary version. That information then gets transmitted into our Kayenta service, which is actually the judge. Which is going to judge whether these metrics are either a positive or a negative improvement, and it's going to do some fancy analytics, you know, statistical analysis on that data, and it's then going to say, well, this is the score. And so that's how this is going full circle. Right? That's how it works. So maybe I have a little bit extra time. I got 10 minutes left. So I actually wanted to show you as well in the Canary config here. So we have a Canary stage which uses a config where you can have your metrics defined. Now you should be careful in selecting which metrics you want, right? You shouldn't just be using any metrics. They should be your key service health indicators. But they can also be business metrics, and I think that's the key one. Having business metrics in here helps you to determine whether your application is actually still working, is actually doing a good job. It could be that you have an e-commerce website and you have this button, add to basket. And if you just check your system metrics, everything's working, even if you remove that link, right? If you remove the button. It's still working, but your revenue is going to be pretty disastrous, right? So having some business metrics, in our case it's Rick and Morty metrics, can help you to make sure that you have much more value out of this Canary analysis. So these just link into whatever Datadog metric that you have available if you would be able to see this. It also helps to, you can also integrate this with Prometheus if you don't have Datadog, of course, or in Stackdriver if you're running on Google, and all that stuff is just easily accessible. So this is how that basically works. Let's go to the final slides here. These are some best practices to help you fine-tune your Canary analysis. So we saw that we had like 8 instances in total, where there was 4 instances of production, 2 instances of the baseline, and 2 instances of the Canary. Now, that's not really great, because our Canary now is going to receive a lot of traffic right away. And we probably don't want that. Right? We want to be very small first. Our blast radius should be smaller. Right? So having more sophisticated load balancing mechanisms in place, where you can say, I just want 1% of my traffic to see this Canary, that's very useful. And if you use something like Istio, you can do fine-grained traffic splits. You can even do content-based routing that decides whether a user can see this Canary or not. Right, so that's something that you should be looking at. But like I said, your metrics, that's the big deal, right? You should really look at which metrics you want to track, and you should fine-tune them. So you should iterate on which metrics you're actually looking at. And aside from just the key service health indicators, business metrics are important. And I can help you out with that, because it's not always easy to reason about which business metrics could be useful. Could be KPIs that you want to track. Could be also the pirate metrics. Has anyone ever heard about that, by the way? It's mostly like product managers that think about this stuff, but it might be useful for you as a developer as well. Pirate metrics are just some business metrics, some business concept you might think of, like awareness, acquisition, activation, revenue, retention, and referral. So you might realize why this is pirate metrics, right? Exactly. And some other best practices. So make sure you run them long enough. Here in this demo, we ran them for what, like 3 minutes or something. In total, 6 minutes if it would be green. This is definitely not long enough. If you look at a normal Canary run, normally this is hours, if not days. Because why not? Right? The more certainty you can build in your deployment rollout, the better. Right? It's all about making sure this blast radius is as small as possible. And you don't have to take unnecessary risks. And you're already exposing this feature to production, right? So it's not like you're losing speed, because you're already reaching customers. Also, metrics, if you want to define them, it might be hard to select the right metric expression that you need to use. And then I would advise you to look at your metric store for a UI or some kind of an explorer that you could use, where you could then fine-tune your expression and then use that in Spinnaker. So that works out of the box that way. So using these explorers can really help you to figure out how you should look at your metrics. You can also use series aggregators and reducers in Spinnaker to help you to align the data points from Canary and baseline deployments. And since this is Spring Boot, you can use Spring Expression Language, actually. So that's what we can use for instance, if I check here in the manifest here, you can see there's placeholders here, like version, and eventually this is also the deployment type that we saw during that flow. So this is just being resolved at runtime. So you can inject stuff from Spinnaker into your manifest, and then you can avoid having these files, all this stuff here, which is hard-coded stuff. And you can just have one left, right? That's pretty useful. All right, so that brings me back to where I started. So Canary analysis, but also all the other techniques that we talked about in the past. They're all here to make sure you can speed up going to production without losing confidence, right? With actually increasing the confidence, without being reckless about it. Right? So you can go fast, but still have safety built in. And that's all what Spinnaker is about. It's about making sure that you can have continuous delivery in a way that just is not really increasing the risk. So if you want to know more about this stuff, I advise you to go to this website, spinnaker.io, and to download this book. It's a free ebook. It's only a couple, like 70 pages or something. You know, it's really interesting read, because it goes more into detail about everything I talked about today. And it's also about the concepts, right? It doesn't have to be specific to Spinnaker. It's just concepts that we talked about here can be used in other tools as well. But Spinnaker really has this support built in. And there's also other talks about Spinnaker. So today we had a talk right before mine, but it's going to be recorded, so you can definitely check that out on YouTube. So the reality of managing microservice deployments at scale you need Spinnaker. That's about a customer story. A big bank that actually used Spinnaker and is still using Spinnaker, of course. Also, today, square pegs, square holes, CI/CD that fits, talks about KPEG for CI and Spinnaker for CD and how they can complement each other. Then we've got tomorrow, we've got highly available and resilient multi-site deployments using Spinnaker and SDLC for pivotal platform powered by Spring Initializer, Concourse and Spinnaker, how that all fits together. So there's plenty of material here to dig into this more. And also, of course, if you got questions, reach out to me. My slides are on Speaker Deck. You can also reach the entire Spinnaker community, by the way, by going to Slack, spinnakerteam.slack.com. Netflix, Google, everyone's there. Right? You can just ask questions about whatever you would try to do in Spinnaker. And on Stack Overflow, you can just check for the tag, and you can go to the website, spinnaker.io. All right, so I want to thank you a lot for being here. For staying in this talk. And if there's any questions, let me know. Maybe now or after, it doesn't matter. But thanks a lot for coming here. Cheers. Yeah, so the question was what's the easiest way to get this set up? And I would say if you have an account on Google, that's really the easiest way. So there's a one-click deploy there to deploy this on a GKE cluster, and it's taking a microservice called Halyard, which is built with the sole purpose to do configuration management, upgrades, and rollout management to actually get this stuff set up. Right, so just having that one-click deploy will set up Halyard, and that Halyard will set up everything else. So that's going to be really easy. But you could also just deploy it yourself if you really want to. But I would advise you to look at Halyard. It's going to be useful. Yes?
Talk a little bit about support for serverless style services in AWS.
Right. Yeah, serverless. Is there support for serverless? So I'm aware there is something for Lambdas for Amazon. I'm not sure how far that's advanced. I'd have to check. But I think it can actually integrate pretty well. But I'm not sure if it's already production ready. But it's definitely something that you can check on the website. I think on the GitHub as well, there's some issues on that, I think. Anyone else? Yes.
Do you know if there is integration with register container from AWS for putting the images?
For pulling images from
AWS register containers?
yes, is AMIs or which containers?
Docker containers from AWS.
Yeah, sure. I mean, if it's a Docker registry,
Docker
yeah.
registry from AWS.
Yeah, sure. I mean, if it's just following the normal Docker registry API, then yeah, that's going to work. It's not just GCR. You know, it can also run with any other Docker registry, actually. Yes.
Is there a way to group multiple applications to be deployed at once? So if you need a new feature, you have 3 components, you want to get them up in a Canary deployment at once.
Right. So the question was, can we group applications and have them in one pipeline?
One Canary with a baseline, as you have a major feature, you want to introduce it on the UI as well as the services. You want to make sure that it's...
Right. So I think the approach there would be best to have still the perspective of an application, but in your Canary you can have other metrics involved as well. So I suppose you're still rolling out one application at a time, even if they're dependent on each other, even if they're a cluster, right? So then you can have your Canary check also other metrics, not just the one from that specific application, and also take that into account. So there's some stuff that you can compose as well. I'm not sure if it would be a good idea to have them all deployed at once. They're not really microservices in that sense, right? Yeah. Well, but it's a good question, actually. I have to look at that. I actually got a lot of questions also the last days about deploying stateful applications and monolith approaches. So Spinnaker is really conceptually built for microservices deployments, but I think it can be done. It can be used for just stateful monoliths as well, right? It's just deployments and automation that helps you with that. So yeah. Is that an answer?
Yeah,
Kind of.
I'm just thinking, right? Because sometimes you have new endpoints you're exposing, right? And you want to have some additional rules in your gateway, for example,
Yeah.
which block access or apply some special access, right? So you need them actually both at the same time being there, even though all your other services don't change. They're backwards compatible and like a microservice. This new endpoint needs some protection or some backends
Yeah.
in order to function. Right?
So what you could do is you could run a script as part of your pipeline that then updates the API gateway, for instance, so that you could register your API change there while part of your pipeline. That's something you can definitely do. Yeah.
There's not such a concept in Spinnaker to kind of combine.
There's actually the project concept.
Okay.
I can show it here. So we have projects here, which can consist out of multiple applications, but they are. It's more like a project management grouping thing. It can also help for RBAC, for security. You can group things together, but eventually they would be separate like this. These applications are here. These here are actually not registered necessarily at Spinnaker. If I scroll down here, there's some stuff here that is also like even the microservices from Spinnaker itself are being discovered. Right, that's also a powerful feature. Like you don't need to register any application here to have them visible. So if I look at Spin, there's stuff here out of the box, right? By just introspecting these cloud environments. This maps to one application because it finds one application as a deployable unit, right? So having that as one group of applications, I don't think that's going to map very well. But you can have a project for that. Right. Any other questions? Yeah.
So if authentication is commonly implemented through SSO, SAML, what are good design patterns for OTZ, like role-based access control?
Yeah, I got asked that question before as well. So the question is, how can you do authorization if you have SSO with SAML or something like that? So you can have RBAC controls. If you have, for instance, Kubernetes, if you're using Kubernetes, you can have namespaces there that are then linked into RBAC, which you can then link into SAML, right? That's a common use case, I think, because everybody wants to make sure that a team cannot access another team's applications or screw something up, right? There's definitely documentation about that on the website, how to do that. I have not personally set that up yet, but I think definitely it's possible. But based on namespaces, I think, if I'm not mistaken. I think. Anything else? Yeah?
So you mentioned it does automatic rollback. So if the pipeline is deemed successful at the time, then a day later or a week later, you want to roll back for some reason,
Yeah.
can you still do that?
So the question is, can I roll back after a couple of days? Definitely, yeah. There's no problem. So there's even the possibility, if I go back to my app here, I don't know if it's readable though, sorry about that. So my app is running here. If I take this deployment here, well, let's take production, right? Then I can now, while this stuff has been deployed days ago, right? Maybe even weeks ago, I can do undo rollout, and if it's visible here, I can just select which revision I want to go to. And that's still there. As long as I didn't actually remove the complete resource from Kubernetes, then I just scaled it down to 0, it's still there to roll back to. And your pipeline can use that information as well to roll back whenever it wants to roll back. Pipelines could run for multiple days.
Do they keep the revisions? Is it based on time or is it based on number of revisions?
The numbers or...
I see 4 revisions here, right?
Mhm, yeah.
Are they there for like a year or something? Or does it
No, so I've specified here. So you can specify, of course, in Kubernetes, what is your revision history limit? So that's the question was, sorry, how does that amount of history actually get preserved, right? So it just, for instance, production, you would have more, you would have 4. So in total, you'd have 5 versions, the active one and 4 history versions. And then you can just roll back to that as long as you don't deploy a new one, because then the last one will be removed again. But if you work with Cloud Foundry, it works a little bit different. But yeah, you can just keep as many as you actually want. Yeah. You sure?
You have mentioned Istio, so it does have integration with Istio?
Yes, it has integration with Istio. And if you want to know more about that, I advise you to look for Istio and Spinnaker on Google Next. So here, Google Next 19, there's a talk about that, and it goes in great detail about how that works. So you can see here, it talks about how Istio can help you with this more fine-grained load balancing, which is really useful for doing Canary analysis, right? It's not just deploying a Canary and then just doing that analysis. It's also about how you actually increase traffic, and Istio can help with that. So definitely check out this talk. You can see here that the Canary, in this case, if you can actually read this stuff, is actually increased by 10% every step, and there's a Canary analysis every 10%, which is pretty cool, right? And this is actually what you should be doing, I think, personally, when you want to roll this out with more confidence. Right. Any other questions? Yeah? Bamboo. Yeah, so the only thing that you should do is your Bamboo should put an artifact in an artifact repository, which is mostly, I mean, most CIs can do that, right? And then from there, you should have either a webhook or you should have push or pull, you know, to Spinnaker, and it's perfectly possible. The only thing that you might be missing is some information about the history of that artifact, through which these integrations are available. So I don't think there's an integration specific for Bamboo. It wouldn't be too hard to contribute that, of course, but yeah, if you want to do that. But the provenance information about your artifact should then come from an API. So you should call that API to get more information about that. But that's only necessary if you really want to trace that back to the commit or to the build, right? So it could definitely work. It's just not the same feature set that if you use a supported CI.